Okay, here we have 3 more problems of aldehydes and ketones. These are nucleophilic additions, so let's analyze what is the nucleophile, what is the electrophile, as we always do. So here you have cyanide, and that is my nucleophile. I know that the carbon here is electrophilic, it's electron deficient, so I'm going to have the nucleophilic attack over here, and what I do is I'm going to put it here better because of the space. So I'm going to have, this is now attached to this cyano group. This is now becoming a cyanohydrin. So the second step, if you have diluted hydrochloric acid, so you're going to do a protonation of the O negative here. So you're going to have OH and CN. So that is a cyanohydrin. What this means is essentially a buffer. We will have KCN in HCl. With that, we also form in situ HCN. So we have these species there. So that essentially nucleophilic attack, proton transfer, right? So nucleophilic attack is the first step, and I did this is the initial product, and then you do a proton transfer. Okay. So now the reaction here underneath is showing there's an aryl halide of bromobenzene, and you're reacting that with magnesium. The N is not that clear. Okay, magnesium. What this is creating a Grignard reagent. So I'm going to do that. It's reaction 1. The product is phenyl magnesium bromide. And now I'm going to say this positive, this is negative, essentially. And the second step is going to be a nucleophilic attack. Now we need to see where. Now I am having, this is an epoxide. Now we have a carbon here and a carbon here. This reaction is now an SN2 attack. And it will happen here at this carbon because it's the least substituted. There's more steric hindrance here. So you will do the attack over to this carbon, and this will open up. So what we are going to have is, I'm going to do this line. I'm going to have O negative. I'm going to have that. And here I'm going to have a phenyl. I'm just changing this drawing a little bit. Of course, I had here 2 hydrogens that are not pictured, which is still there. So by that is your initial process. So you will open up the epoxide again, having the attack on the least substituted carbon. That is the more reacted towards ESN2. And the final step here, let's draw a line, is a proton transfer, and your product will be the alcohol. That. So that was a Grignard reaction, only that what is the electrophile here? The carbon here at the epoxide, these, the least substituted. Okay, now in the reaction below is another example of a Wittig reaction. Here I have the halide, and again, to better see what's going on, we're going to do the resonance structure. In the resonance structure, we'll have this. So I'm moving those electrons over here to make a double bond with the phosphorus. Now I don't have any charges, and what you are inserting where the O is this piece. So I'm going to draw the product. So here you will have 2 metal groups, and that's it. So relatively easy if you remember that from the halide. If you do this, easy to replace the O by that and make the alkene.